Similarly, we will check for any planted columns. As you can see over here, we have a multiple number of planted columns all around the edges of the slab. Why they are provided? They are provided for the purpose of block work, because when we are going to make the block work from this edge to the other edge of the slab, we can't just make it straight. We have to make several joints in the form of these minor or small columns. So these columns are planted over here. They are not coming from the bottom, and we have to take care about this also, that if we have a parapet wall of almost 1 meter 20 centimeter or 1 meter 40 centimeter, so we have to provide all these columns to bind the block work together. So if you can see over here, we have all these small columns all around wherever we have parapet. And on the other hand, we have a next floor over here, so we will go up. In this region we will go up, so the dowels are left over there deliberately. After this, we will come to check the thickness or the depth of the slab at different points. Let me check over here. If you can see, the mesh depth is 19 centimeter. It's 19 centimeter. So it means we have a clear cover of 2 centimeter in the bottom and 3 centimeter at the top. So it will make 24 centimeter of slab. 24 centimeter of slab. Coming to the edges of the slab, you will check the shutter over here. So you can see it clearly now. It's 24 centimeter. So you will check all around, near the edges, in the middle, to ensure that the depth of the slab is as per drawing. After checking the depth of the slab at various positions, we will now check the beams, its locations and the sizes, cross sections. So if I can show you, this is the column. One drop beam is running over there in the straight direction. One drop beam, it is coming from the left side, from the other column sides, and to the right side we have a hidden beam. If I can show you clearly the section. So this is the hidden beam. If you can see over here, we have 1, 2, 3, 4, 5, 6 number of bars on each face. So it means 12 bars of 16 mm bar have been used over here, and we have 2 rings at one place. One ring that is binding all the 12 bars to each other, whereas these rings are binding together the center 4. The 4 bars of the center, they are binding together. So at one place we have 2 rings. It means the rings are 4-legged over here at one place. So in this way you will check all the layout of the beams and the sections. One more important point I want to discuss over here. At some places in the beams you will have pipes, you will have conduits, will have sleeves for the MEP works. For example, this is meant for the plumbing works, for AC drainage. So if I can show you the drop beam over here, so you will see we have actually 3 number of bars in the bottom, but according to the specification or principle, the bar must be in the middle, one on the left, one on the right, and the third one must be in the middle. But we can't proceed it over here, we can't bring it in the center because of this pipe, because this pipe is resisting, or it takes the center of the beam. So if you can see over here now clearly, we have 3 bars over there, 1, 2 and 3. It must be in the center, but due to this pipe we can't take it in the middle, we can't bring it in the middle, so we have diverted it to one side. So this is common practice, there is no big issue in it. If you can see over here, all the 3 bars in the bottom we have spaced equally. So in this way you will check all the beam layout according to the drawing. In my case, now if you can see over here, the drop beam that started from that end, it stops over here on this column. Then we have cantilever edge, we don't have beam over here. On this edge we have cantilever, and then from this column the drop beam starts again and it runs over there at the end. So the drop beam may not be necessarily running all over the slab. It may be existing at some places, or at some places it may be not existing due to design. So keep this in mind. Now we have 2 meshes. One is the top mesh that I'm holding now. This is top mesh. This is in X direction, this is in Y direction. And one we have this one, X direction, Y direction. So we have 2 layers basically that are called the meshes. The mesh here is of 20 centimeter center to center, and it is from 14 mm bar. The overlap must be not less than 50 times of dia bar. At the OTS areas we must have extra bars all around, as you can see from here. Extra bars 16 mm all around in a rectangular position, X and Y direction, at least 4 bars, 2 at the top and 2 at the bottom, and also in the diagonal position at the corners, because there are too much excessive loads on this area, because there is no beam here and it will remain open, so the edges will experience more forces. To counter that forces, we have to give some extra support in the form of reinforcement that you are seeing now. After this, we will check the extra bars in the bottom and extra bars in the top. So if I can zoom it here and show you the reinforcement, so you will see all these bars are extra bars in the bottom. They runs from here over there as per drawing. So this is the bar of regular mesh, similarly this one, and this one in the middle is the extra bar in the bottom. Similarly, this is the top mesh, and if you can come over here near column, so we have a number of extra bars in the top around the column. For example, this line, if I can start over here, this is 1, this is 2, 3, 4, 5, 6, 7, and it's almost 15 at one side, 15 on the other side of 16 mm bar. Similarly, we have these links. If you can see over here, we have these links or hooks that are meant to resist the punching shear of the column. Because this is flared slab, so there is almost a punching shear forces near the column, surrounding the column, in the vicinity of the column. So we have to provide all the necessary support in the form of reinforcement part resisting this punching shear. You can see over here we have extra in the bottom. If you can see over there, we have 16 mm of bar here is extra. So the length and the position will be shown on the drawing, on the shop drawing. The number of bars or sometimes the distance will be shown on the drawing as well. Top reinforcement, you can see over there, extra reinforcement. Also, we will have punching reinforcement over there. So all these are meant to resist the punching shear forces of the column as it is flared slab. Here we have 20 mm of bar in the top reinforcement, in the X direction and in the Y direction both. Almost 15 bars in the X direction, 15 bars in the Y direction. Similarly, we can come over here. Around this column we have 20 mm bar as top reinforcement additional bars. But no punching reinforcement because it may not require as per design. Similarly over here we have additional reinforcement in the top mesh over here as well. We have additional reinforcement in the bottom over here, if you can see over there. The length of this one I will give an approximate, it's almost 5 meter. Similarly, the top reinforcement additional one. Here we have a column that has been terminated, but still there would be shear forces punching, so they provide the punching reinforcement. A question may be arised in mind that how to locate these columns. So these columns are coming from the below floors, but we have to check it again. So there are several methods. One of them is to take the dimensions, to take the coordinates from the AutoCAD drawing and then bring surveyor to mark the points of the columns, all the corner points, so that you may not miss the alignment or the verticality of the columns. Similarly, the same procedure will apply for all OTS positions. The second method will involve taking the dimensions from any fixed point. For example, if I want to locate this column, so I will have a fixed point over there, for example, that shear wall or that column, the other column, the staircase area. So I will take dimension from there as well. So that are the two methods that are used to locate the columns and the other details such as OTS. How to bring this perfectly rectangular? So you have to take dimension from all sides, that the dimension of that side must be equal to the dimension of this side, or simply I can say the diagonals in this direction and the diagonal in this direction must be same. It must be checked by Pythagoras theorem. Right angle must be straight over there. So you will have an opening of equal size, perfectly rectangular. The same will apply over here, that you have to apply the Pythagoras theorem over here, so that you have to bring a rectangular opening over here. The other things that you will check is obviously cleaning and the provision of cover blocks. So if you can see over here, we have multiple cover blocks that are spaced almost at 1 meter apart. So we have sufficient number of cover blocks over here. Also you will check the mesh firmity, that it is firm or not, it is loose. So you will exert pressure by your leg on the mesh at different areas. Is, if I can show you, I am applying pressure over here now. So it is not jerking too much, or it is not producing any sound of the steel bars. If I can, you can just imagine. So this is quite acceptable work, and the steel binding is good. Also the cleaning has been done now. The cover blocks are put at reasonable good distances. The MEP work has been completed now. Tomorrow the municipality representative will come and they will inspect the slab